Okay, question 1. Given triangle ABC has vertices at A, 3, 7, B, -1, 1, and C, 5, -3. Point D lies on segment AB. Point E lies on segment AC. Segment DE is the mid-segment of triangle ABC. Prove that segment DE is parallel to segment BC without using the triangle mid-segment theorem. Alright, the triangle mid-segment theorem just says that mid-segments are automatically parallel to the base, to the opposite, to the side that they're not ending on. So that's what the triangle mid-segment theorem is. So they're wanting us to use it with slope. So just going through this, triangle ABC has vertices at A, 3, 7, B, -1, 1, and C, 5, -3. D lies on segment AB, E lies on segment AC, segment DE is a midsegment of triangle ABC, so they just restated what was given. That is the reason. Point D is the midpoint of segment AB, and point E is the midpoint of segment AC. I'm noticing that point D and point E are both endpoints for segment DE, and that they had stated that segment DE was the midpoint, was the mid-segment of the triangle. So if I were not sure what mid-segment meant, I would go to the definitions and I'd click mid-segment. A line segment that connects the midpoints of two sides. So the reason that they are midpoints is because it's a mid-segment. So that's the definition of mid-segment for blank triangle mid-segment right there. So blank 2, point D has the coordinates blank midpoint formula. Okay, the reason I love graphs is because I didn't have to do a formula. I can just look. Okay, it's over 1 on the x-axis and it's up 4. So the coordinates are 1, 4. Okay, blank 3. Point E has coordinates blank. Again, they say midpoint formula. Again, since there's a graph, we can just go over and use it. So 4, 2. That is a good use of tools, is using a graph. So if it's there, then use it. Blank 4. The slope of blank is -2/3. Slope formula. The slope of segment BC is blank. Slope formula. And segment DE is parallel to segment BC blank. Okay, the reason why I read from statement 5 on is because there wasn't really a lot to go off of in statement 5 to give me an idea as to what they were talking about. So I went to statement 6. They're talking about segment BC, and then I went to statement 7, and they're stating that segment DE is parallel to segment BC. I see BC right there. I do not see anywhere in segment DE, so I believe blank 4 is segment DE, and I'm going to check that the slope is -2/3. So from point D, remember your slope is your rise over your run. So from point D, we went down 1, 2, there's the -2, and over 1, 2, 3. So yes, segment DE slope is -2/3. So that's how I would use just the clues from the statements to figure out what blank 4 is. So blank 4 is segment DE. Blank 5, the slope of segment BC is blank. Well, we can figure out what the slope is from B to C. We're going to count how far down. So it went down 1, 2, 3, 4, down 4. So since it went down, it's negative, and over 1, 2, 3, 4, 5, 6. So -4, 6 reduces down to -2/3. So the slope of it is -2/3. Alright, so now we have the statement segment DE is parallel to segment BC, blank 6. Why? Well, they just said something about being parallel in the statement, so I'm going to look for a reason that includes parallel. And they used the slope formulas, so I'm going to look for a link between slope formula and parallel lines. So in the options, slope criterion for perpendicular lines, no. Segment bisector, no slope criterion for parallel lines. Yes, they were using the slope, and they had parallel lines. So then I would go up and I would check key terms again and see if they had slope criterion for parallel lines. Or right here, parallel lines. Two coplanar lines that never intersect. That doesn't really tell you anything. So I would just use the context clues to answer that question if you didn't have that written down in your notes. So now that we know that, I would write this down as an example so that I could refer back to it later on and see how a proof flows with these given things.